today's video, we are going to cover dilations. Our learning targets for today are I can identify a dilation, I can find the coordinates of a figure dilated with respect to the origin, and I can use the coordinates to dilate a figure with respect to the origin. Dilations. So a dilation is an enlargement or a reduction of a figure with respect to a fixed point called the center of rotation. Now the most common center of rotation is the origin. A dilation is an example of a non-rigid motion in that it does not preserve congruency. So a dilation produces what's called similar figures. Now in a similar figure, all corresponding angles are congruent and all corresponding sides are in proportion to one another. Now when we make dilations, we use a scale factor. So the scale factor indicates how much the figure will either enlarge or reduce. The variable that we use for the scale factor is k. Now when k is greater than 1, the dilation is an enlargement, making it bigger. And when k is less than 1, the dilation is a reduction, making it smaller. Now for our rule, if we have the regular pre-image coordinates of x, y, then after a dilation around the origin with scale factor k, we'll have x, y will change to kx and ky. So looking at an example, if we want to find the coordinates of triangle RST with the following vertices after a dilation with a scale factor of 2, I will need to multiply each of my coordinates by 2 to find my dilation. So R being negative 5, 1, if my scale factor is 2, I'm just going to double it. So then it'd be negative 10, 2. T is 2, negative 1, so that would go to 4, negative 2. And then S is negative 3, 4, negative 3, and 4 times 2 would be negative 6 and 8. Now drawing in these coordinates, I would have the following image triangle R prime, S prime, T prime. Looking at number 2, I'm given rectangle ABCD with the following vertices. I want to make a dilation of scale factor 3. So I'm going to multiply each one of these coordinates by 3. So A is negative 3, 0. 3 times negative 3 is negative 9. 0 times 3 would be 0. So A prime would be negative 9, 0. B, 1, 2 would be 3, 6. C, 2, 0 would be 6, 0. And D, negative 2, negative 2 would be negative 6, negative 6. I'm just multiplying each one of my coordinates by the scale factor. Now drawing in these coordinates would give me the image rectangle A prime, B prime, C prime, D prime, which would look like this. Looking at number 3, we have rhombus JKLM with the following vertices. I want to make a dilation with the scale factor of a half. So notice I have J at negative 10, 2. If I multiply negative 10 and 2 by a half, I'd have J prime of negative 5, 1. K is negative 2, 8. If I multiply negative 2 and 8 by a half, I'd have K prime of negative 1, 4. L prime would go to 3, 1. And M prime would go to negative 1, negative 2. Now drawing in these coordinates, I would have my image rhombus J prime, K prime, L prime, M prime, which would look like this. Now looking at a few examples where I'm going to identify my scale factor, I'm given two figures, one image and one pre-image, and I want to see either how much I enlarged it or how much I reduced it. So if I take the coordinates of my image and divide those by the coordinates of my pre-image, it will give me my scale factor. So again, my coordinates of my image divided by my pre-image will give me the scale factor. So looking at number 15, I have D coordinates of 0, 6, and then D prime coordinates of 0, 2. So notice if I take 2 and divide it by 6, that gets me a scale factor of 1/3. And if I also notice my pre-image was larger than my image, so I should know that my scale factor should be less than 1. So if I reversed my coordinates and said 6 divided by 2, which gave me 3, I should know that it would be 1/3 because this should be a reduction since my image is smaller than my pre-image. So 15, we have a scale factor of 1/3. Now 16, if I look at my pre-image coordinates, my pre-image is smaller than my image, So I know this should be greater than 1. So if we look at, say, y is 1, negative 2, and then y prime is 4, negative 8. Now, if I take either my x or y coordinates, 4 divided by 1 gives me a scale factor of 4. Notice how I just use one of the coordinates to find my scale factor. I don't need to use all of my coordinates because each coordinate will use the same scale factor. In this lesson, we learned a dilation is an enlargement or a reduction based on a scale factor. To make a dilation, multiply each of the coordinates by the scale factor. That's a wrap on this video. We'll see you in the next one.